Ms. Smith, I received your question about, let's see, on page 21 or section 1.2 on the computer, you said it's 6 through 10. I just decided to work the first one here. In the book, it's number 25, which corresponds to number 6 on the computer. Okay. What you want to do is, one thing you want to look, we have this triangle we discussed in class. It's on page 16 in the book here. And we discussed the 45, 90 degree triangle. And if one side, it's an isosceles triangle, if this side's 1 and the side opposite's 1, then you could use Pythagorean theorem, the hypotenuse is square root of 2. Then you can use this along with Euclid's theorem. If you have another 45, 90 degree triangle, these are similar triangles and the sides are in proportion. And so what the problem I asked you for was to find, I guess, the length of these other two sides, find the length of this leg and the hypotenuse. Well, up here, if you got a 45 triangle, if one leg is 1, what this says, the other leg has the same length. And so the other leg, would be 4. And then over here, if each leg's 1, they're the same. The hypotenuse, is a square root of 2. And so over here, the hypotenuse, is going to be, we could set up a proportion, or it's going to be square root of 2 times 4. If we want to go into Euclid's theorem, we could call this x, then, like x over 4 would equal square root of 2 over 1. What I'm doing here is, here's x over one of the sides, 4, would equal square root of 2 over 1. Using Euclid's theorem, these sides are in proportion. Then you just cross multiply to solve that, and so x would equal 4 square root of 2, which they may want you to put in the calculator and get a decimal. Hope this helps.